Okay guys, so our next lesson is 5.2, exploring translations of quadratic relations. Oh, I need my pen. Oh, there it is. Okay, so some of this will be review. The majority of the review was yesterday. Now we're going to be looking at shifts, so vertical shifts, the parabola moving up or down, as well as translations, which we call a horizontal translation. This is probably going to bring my mask down a little bit. So, we're used to seeing something like y equals x squared, right? Or y equals 3x squared, y equals negative 2x squared, right? This is what we did yesterday. And then we would plot the points, we'd make our table of values, we'd make our graph, and that sort of thing. We'd get our step pattern. Whereas now, we're going to see more values added to the equation. Okay, so here we see y equals x squared minus 2. So again, we're going to be able to look at translations now. So shifts up and down, and then horizontal translations, the parabola moving left or right. Okay? So the first question here says, make a table of values and graph the function. Okay, so that's nothing's new there, right? We're just going to make we're going to use our equation, we're going to sub in our x values so that we can get our y, so that we can plot the points here. So, negative 3 squared is? What's negative 3 squared? Right, because we're going to sub our negative 3 in for our x. What is it, guys? What's negative 3 sorry? 9 minus 2 is? 7. Okay, are we okay with what I'm doing there? I'm just going to fill in those values. So if we sub in 2, we get 2, negative 1, negative 2, negative 1, 2, 7. Okay. Starting at the vertex, calculate the step pattern. Okay, so first we're going to plot the points. So you guys can do this as well. Negative 3 and 7. Negative 2 and 2. Negative 1 and 1. 0. Oh. Sorry. Negative 3, 7. Negative 2 and 2. Negative 1 and negative 1. My bad. 0 and negative 2. 1 and negative 1. 2 and 2. 3 and 7. Okay, so everyone should have something that looks like that. Starting at the vertex, calculate the step pattern. So you guys tell me. So I'm starting here. I'm going to go over 1. And then up 1. Over 1. Up how many? Over 1. Up how many? Job. So, calculate the step pattern. 1, 3, 5, 7. That makes sense, right? Because we don't have a number greater than 1 in the A spot, with the A value, right? This is a 1 here. So we know that when that's a 1, that's our basic step pattern. If it was a 2, then we would have 1 times 2, 3 times 2, 5 times 2, right? So that makes sense to us. So what do you notice from the original step pattern of y equals x squared to the step pattern of y equals x squared minus 2? So I pretty much just said that. It's the same. So even though we have this minus 2 added to the y equals x squared, the step pattern hasn't changed because the a value has not changed. What do you notice from the original vertex of y equals x squared to the vertex of y equals x squared minus 2? Well, what's the vertex of y equals x squared, guys? 0, 0, right? That's the same vertex that we always have every single time. So really, y equals x squared is 0, 0, But what's our vertex of y equals x squared minus 2? What's the vertex? Here. 0 and negative 2, right? So what do we notice about that? Vertex shifted down 2 units. So that's important. Okay, we're going to do a few of these examples. You'll notice because we had a negative 2 here, that caused the parabola to shift down 2 units. Okay? Questions about this slide? Next. Consider the following relation. Y equals negative 2x squared plus 8. So make a table of values and graph the function. Okay, so same thing. We're going to plug in our x value into the equation. So negative 3 squared is 9. 9 times negative 2 is negative 18 plus positive 8. So negative 18 plus 8. Negative 10. Okay, so just, I always like to do the first one with you so you know how I'm getting these values. Okay, we're going to plot this. Negative 3, negative 10. Negative 2, 0. Negative 1, 6, 0, and 8. And then I just come over here. Okay, just plotting the points here. You okay with that? Start at the vertex, calculate the step pattern. So we start here, we go over 1, and then down how many? Over 1, down. Good. Over 1, down. This is 10. Now, we did that by just looking at the graph. What if we were to actually use our 1a, 3a, 5a? So 1, what's my a value? So 1 times negative 2, 3 times negative 2, 5 times negative 2, we get negative 2, negative 6, negative 10. Okay, we're okay with that? What do you notice from the original step pattern of y equals x squared to the step pattern of y equals negative 2x squared plus 8? Well, we noticed that we can just multiply by the a values. We can take the basic step pattern, which is the step pattern for y equals x squared, and we can multiply that by the a value, which in this case is negative 2, and that gives us our new step pattern. So I'm just going to say multiplied by negative 2, which is the a value. Now, what do you notice from the original vertex of y equals x squared to the vertex of y equals negative 2x squared plus 8? So what's our original vertex again? What's my vertex for y equals x squared? 0, 0. My vertex of my new equation here is what? 0 and 8. So what do you notice? what changed here? It shifted up or down? Shifted up. Do we know how many units? 8. Good. Okay, so that's another thing. And we're going to do a table that summarizes this all together. But you'll notice this said plus 8. And because we had that plus 8, it has shifted our parabola up 8 units. You okay with that? Questions? Next. So we're going to compare the graphs of y equals x squared and y equals ax squared. Okay? Don't let this confuse you. This is nothing new here. This is like saying we're going to compare y equals x squared and y equals, let's just say a is 2, 2x squared. What is the difference between these two? Okay, and we've done a lot with these two. This is really a review table, if anything. Okay, so if we have y equals x squared, what is the value of a? Where's our a again? Right here, right? Right in front of our x. So for this guy, what is it? Okay, 2 here. Right. Are we okay with being able to pick that out? This is our a value, right? Direction of opening. Well, what do we look to for that? The sign, right? So this first guy is going to open up or down? Up, because it's positive. Up. Up. This guy will be down. Down. Vertex. So now think about it. Y equals x squared, what's our vertex? What's our, say, 0, 0, right? So these equations here, yes, the a value changes, but we don't have like a plus 2 or a minus 8 here that's going to change the vertex. So the vertex stays the same, okay, because we don't have that extra number in the equation. So if the vertex is 0, 0 for y equals x squared, well, it's still 0, 0 for all of these equations as well, because we don't have a shift up or down. Okay, so really just comparing graphs here. And then lastly, the axis of symmetry. Who can remember, where do we get that value from? X equals. X equals, we did this like a couple weeks ago. If this is our vertex, and our axis of symmetry we always say is x equals. Well, where does that x value come from? The vertex. Okay, so we can't forget that the axis of symmetry is always the x value of the vertex. So for all of these, x is going to equal what? Good job. Okay, I just want to add this in, too. So I'm going to just say x value of vertex. Step pattern. What's my step pattern for y equals x squared again? Step pattern for y equals x squared. My basic step pattern. 1, 3, 5, 7. I feel like we're quiet today. So, if we have 2 here and 0.5 here, we need to remember that in order to get our step pattern, it's 1 times A, 3 times A, 5 times A, 7 times A. Okay, and then just reminders. A is positive. It opens up. And if A is negative, opens down. I'll let you guys get that down. Sorry, Alex. Hi, how are you? Good, thank you. Thank you. So Cheyenne, we're just on 5.2. Okay. Okay, so this little bit down here is very important. So it says the graph of y equals ax squared. So it's saying when we have an a value greater than 1, is the image of the graph y equals x squared after a vertical stretch or compression. So remember yesterday when we did our very last lesson in the afternoon, we started to see those words of vertical compression and vertical stretch. So we said a vertical stretch is when a is greater than 1. Okay, so when you have 2, 3, 4 as your a value, that is when we know that a vertical stretch is happening. Okay, and that looks, I'm just going to kind of, that looks like, remember our parabola looked more like that. Vertical compression is when a is greater than 0, but less than 1. So really that means a fraction. Okay, so if we had 1 over 2, okay, that's really 0.5, which is greater than 0, but less than 1. That's when we have a vertical compression, and it looks fatter. Do you guys remember that from yesterday? And then lastly, a reflection in the x-axis. That is the term that we use when a is negative. So I want you guys to put here, opens down, a negative. Okay, so vertical stretch is when a is positive and is greater than 1. Vertical compression is when a is greater than 0 but less than 1. And a reflection in the x-axis is when a is negative and it opens down. So for example, this guy here, negative 0.5, would be a reflection in the x-axis because it opens down, because it's negative, but also a vertical compression because a is greater than 0 but less than 1. Does that make sense? Is that okay? Okay, good. Next. So now we have another table here because we want to compare the graphs of y equals x squared and y equals x squared plus q. Don't let that confuse you. When it says y equals x squared plus q, that's this now. So this is new for us. So the plus q, this is really our q value. So now we're comparing y equals x squared to y equals x squared plus q. Okay, so what's the differences there between those types of graphs or those types of parabolas? Okay, so value of q. y equals x squared. So in this case, we don't have anything here. So the value of q, which is this guy here, is what? 0. Good. So the value of q here? 2. Okay, so we're okay with picking that out. 4. How about here? -1, -3. Good job. Direction of opening. Well, nothing changes here. What are we always looking to for the direction of opening? The sign of the A value, right? So this guy's going to open up or down? Up. They're all positive, so they're all up. Okay. Vertex of y equals x squared. We know this. What is the vertex of our most basic parabola? 0, 0. So now we're going to figure out the vertex of when we have y equals x squared plus q. So when we did this here, guys, we had +8 for q. So what do you notice about the vertex? The y value seems to be the q value in the equation. So keep that in mind as we try to figure this out. So our vertex now is going to be what for y equals x squared plus 2? Good job. This one? This one? Okay, so we're okay with that? I want you guys to put this in. And this makes sense. Value of q. So this number here changes the y value of the vertex. Makes sense, right? If our q here is 2, well, this number changed the y value of our vertex to 2. Okay, and then axis of symmetry. Well, the axis of symmetry is always what? The axis of symmetry is always, what did I put up here on the last slide? The x value of what? So, x equals 0. X equals? Okay, so it's x equals 0 all the way down because our x value is still 0. We're okay with that? Questions about that? You guys can get this down. Yes. Yes, go ahead. Sorry, I just want to say something here. Okay, guys, I know this lesson is quite lengthy, so just bear with me. We just got to get through Block A. And then this afternoon, we have one more lesson, but it's only 5 slides. Okay? And then that's it again for the day. So I know this morning, with this lesson, it is quite long. And I find that with this stuff, we really have to practice, because it can get confusing. Yeah, we're going to be, I think this one's 10 slides. Next slide is 5, so we're almost halfway. Okay, so let's talk about this. The graph of y equals x squared plus q is the image of the graph y equals x squared after a vertical shift up or down. So this is new for us, right? We had 2 examples at the beginning of the lesson where we had a +8, and I think the other one was a -2 for our q value. And we saw, let me show you really quickly, we had -2 here. So this is a vertical shift down. Okay, so when it's a negative, it's going to vertically, okay, so up and down, shift it. Here we had a +8, so it was a vertical shift up 8 units. So I put here in the y value of the vertex. So make that connection. The y value of the vertex is q, right? Q here is 2. Well, the y value of the vertex is 2. Well, this parabola is going to shift vertically upwards 2 units. This would be a vertical shift down 1 unit. Vertical shift down 3 units. Does that make sense? Is that okay? Okay. So vertical shift up if q is greater than 0. So we just talked about that. Vertical shift down is if q is less than 0. Questions? All right. So fill this table in. This is like a summary. Lots of summaries today for you guys to go back to your notes. Yes. Yes, go ahead, buddy. Okay, so once again, we're going to compare 2 different types of parabolas or 2 different quadratic equations. So here we have y equals ax squared plus c. So all that's saying is a specific example would be this guy. Y equals ax squared plus c. Okay? Or in this case, we use q for that. Vertex. Well, we know now after doing the table that the x is still going to be 0, but the y becomes this guy here. Okay, so c or p, sorry, q. Oh, sorry. I'm all over the place. Q. Okay, C and Q, it's the same thing right now. Please don't let that confuse you. Axis of symmetry. Well, x equals 0 because the axis of symmetry is always the x value of the vertex, which is still 0. Direction of opening. Well, is my a value negative or positive here? Positive, so it opens up. And what's my step pattern? Well, we have an a here, so if it's greater than 1, we're going to have 1 times a, 3 times a, 5 times a. Okay, and I know we keep saying this over and over and over again, so some of this really is review. What I want you to remember, and what's very important here, is when this is a plus sign, our vertex moves up. Right? And we just saw that. We just did that. We had +8 in our last equation, and we saw that it moved up 8 units. Okay, and then over here we have y equals negative x. Sorry, I missed the a. Please add that in. Negative ax squared plus c. Well, our vertex is still going to be 0 for our x, but then this number becomes our y. X equals 0 because our x value of the vertex is still 0. It's going to move down y again. Sorry, it's going to open down. It's going to open down, not move down, sorry. It's also going to... Why? Again, remind me. Why is this guy going to open down? Because it's negative, right? And then here we have negative 1a, negative 3a, negative 5a because this is negative. Okay? I want you guys to add something right here. Y equals ax squared minus c. So the difference between these two graphs was a negative here and a positive here. But what if we had minus c here? That is going to tell us, that's right, good job. Vertex moves down. And then my vertex is going to be 0 and negative c. Does that make sense? Because before it was 0 and c, because it was positive here. But now the vertex is going to take that negative into it as well. Okay, my axis of symmetry is still x equals 0, because the x value of the vertex is 0. Okay, this guy would open up, right? Because the a is positive. And then the step pattern would still be 1a, 3a, 5a, 7a. I just wanted to add that one in. Because this is both adding the c. I wanted to show you when we subtract the c. So if you could just add that somewhere. Okay, let's do a couple examples. Okay, and right now we're only focusing on vertical shifts, so moving up and down. But you need to take into consideration that the next few slides, we're also going to look at when it moves left and right, which is our horizontal shift or horizontal translation. Okay, so sometimes you're going to, in the equation, have to pick out the shift vertically as well as horizontally. So right now we're only dealing with vertical. Next we'll deal with horizontal, and then we'll put it all together. Okay, so let's look here. Graph using vertex and step pattern. So y equals 0.5 x squared minus 7. So first off, tell me, does this guy open up or down? Opens up. That's important. Write that down. We have a positive a value. This here is going to shift the parabola up or down. Down. Good. Step pattern. One. Oh, I guess I shouldn't go into the space of the other one. One A, 3A, 5A. What is A? Good. 1 times 0.5, 3 times 0.5, 5 times 0.5, and we get 0.5, 1.5, and 2.5. So we're going to graph that now. What do we need to graph this? Because we don't have a table of values right now. So try to think. What do you think? We have the step pattern. So if we have the step pattern, as soon as we have one point of the graph, we can start using our step pattern to get our other points. So what must we get before we start graphing this? The vertex. Good job. Well, what's my vertex? Well, my x is always what? And where do I get my y? Where did it come from? -7. Good job. Okay, so let's graph that. So 0 and -7. And now, our step pattern is 0.5, 1.5, 2.5. So I'm going to go over 1, up a half. Over 1, up 1.5. Over 1, up 2.5. Same thing on the other side. Over 1, up a half. over 1, up 1.5, over 1, up 2.5. Well, just to go an extra step, what do you guys notice about this parabola in terms of like the terms that we've learned now? Good job, Mason. Vertical compression. And we know that compression is when the A value is greater than 0 but less than 1. And look at, we have that here. We have it could be a fraction. 1 over 2 is 0.5. So you'll notice that this guy here, which is A, just label that. You'll notice that that is a vertical compression. Okay, next. Let's do this one in red. Okay, so right away, this guy opens up or down. Opens down because the A value is negative. This is going to tell us that it's going to move vertically shift up or down. Up, good job. Step pattern. I'm going to do SP for that, okay? What's my A value? -3, so I'm going to go 1 times -3, 3 times -3, 5 times -3, which gives us -3, -9, -15. What's my vertex? My X is 0 and my Y is 10. Good job. Just straight taking the C or the Q value. Okay, so we'll plot our vertex, which is 0 and 10. And then we're going to use our step pattern. So, over 1, down how many? Awesome. Over 1, down 3. Over 1, down 9. Over 1, down, okay, we won't have enough space for that, so no big deal. Over 1, down 3, over 1, down 9. That's as much as we'll be able to do. Okay, and like you see it, look. We know that the vertex of our y equals x squared is 0, 0. Well, this guy has been shifted, vertically shifted upwards 10 units. Okay, this guy here has shifted down 7 units. Questions? Pretty good? Easy peasy? Okay, now we're going to look at translations. Horizontal. So we've just looked at vertical shifts, up or down. Now we're going to look at shifts left to right. Okay, so what about a horizontal translation shift? Let's first graph. Okay, so this here, I'm going to write this, and we're going to do more of this in our lesson in the afternoon. This form here, just write, is called vertex form. And I know that doesn't mean much to you right now. We will look more into it in our next lesson, but we do have to know that that's a vertex form. Which is really y equals, and write this down, x minus p squared. So really, this value here is p. Okay? Okay, so let's first graph y equals x plus 2 squared plus 3 using a table of values. Okay, so that's no problem. We're just going to sub in our x into here, right? So -2 plus 2 is, right, because I'm subbing this guy in first, 0. Good. 0 squared is 0 plus 3 is 3. That's all I'm doing here, okay? Am I okay to just fill them in? Let's do the next one just in case. -1 plus 2 is 1. 1 squared is 1 times 1 plus 3 is 4. Good. Okay, so we're okay with how I'm filling this in. Okay, so now let's graph this. -2 and 3. -1 and 4. 0 and 7. 1 and 12. 2 and 19. So, that's all we have. So what do we have right now? We have half of a parabola. So how could we get the other half of the parabola? We don't have it on a table of values. What else do we know that we can look to or use when plotting points? We just did it on the last slide. Step pattern. So what's the step pattern? So in this case, this is still our A value out front. So what's our A value? 1. So what's our step pattern when our A value is 1? Our basic step pattern. Good job. So we're going to use that now. So over 1, up 1. Over 1, up 3. 1, 2, 3. Over 1, up 5. This is going to be around here. And over 1, up 7. Which is going to be about here. Okay, are we okay with that? I just used the step pattern to plot those points. Okay, so now I'm going to do that. And there we have it. What is the vertex? What's our vertex? You guys tell me, what are the coordinates of the vertex? Okay, so don't let the 0 confuse you. Is this really the vertex of the parabola? No, this is, right? So what are the coordinates? -2 and 3. So I like that someone said that though, because we're so used to it being the 0 value, and in this case, we're having a shift, a horizontal shift. So the vertex is no longer over here, it's over here. Okay, so in this case, you had to actually look to the parabola to say, oh, there's the vertex, these are the values. Okay. Okay, so how is the equation related to the coordinates of the vertex? So it says, what does the +3 do to the y value of the vertex? So I want you guys to fill in here. Up 3. Vertical shift. Now, this isn't new. We just did that. We saw that this value here, our C or our Q, is the vertical shift up or down. Well, we have a positive, which means it's going to move up or down. Up, and it's going to be 3 units. So this first question here, we did that already. We dealt with our vertical shifts up or down. So this +3 is telling us that it's going to shift up 3 units. Now, what does the +2 do to the x value of the vertex? So this value here is a +2. What do you notice that might have done? Do you think it moved left or right 2? What makes sense? We're used to having our vertex being 0 on the x, right? Does that make sense? Remember in all our last slides, our vertex was 0, 0 or 0, 3 if the y value had changed. But remember, we always had our x value as 0, which means that it would have been over here. So did it move left or right? Left. So I'm going to say left 2. And I want you guys to know that's horizontal. Okay, so when we do horizontal translations, this part is going to get a little confusing. So do you guys notice up here that this vertex form has a negative here. Okay? So because there is a negative there, but then look over here, this is positive. So our standard vertex form always has a negative there. So in order for this to be positive, this value here, this p-value, would have had to be -2. And I want you guys to understand why. If we were to then plug in our value y equals x minus, because that's part of this equation, in brackets, -2 squared, this becomes what? -1 times -2 is? So we had to do this, remember when we did our y equals x minus p plus q? Remember a long time ago? This was the same situation, having a double negative. So if I was to say that the actual p-value here is -2, we would go and sub that into this equation. So it would look like x minus, because that's what's there. And then in brackets, your -2. Well, what does this really become? A positive, because -1 times -2 is +2. So that's how we actually got to x plus 2 squared. So I want you guys to remember that it really is like the opposite. So the p-value down here was really, I'm just going to put in brackets, -2. Okay? So it's up to you how you guys want to memorize it. In this case, the p-value was really -2. So when the p-value is negative, you're going to move left. If you don't want to remember it that way, you don't have to. I personally think it makes more sense to just say, if there's a positive here, then we're moving left. Do you guys see what I'm saying? It's really the opposite. Okay, so I need you guys to know that. So if the p-value was +2 up here, then this would still say x minus 2. Because x minus, and if the p was 2, you would just put 2. Okay? So we're going to do more practice questions with that, so you guys will see. Okay. Yes. Yes. When you see an equation that looks like this in vertex form. Okay? So I know that now we're putting everything together, right? So it's becoming a little bit overwhelming because we're seeing all these different scenarios. But if you were to see this x plus 2 in brackets, right? Because we're used to it looking like this. Y equals x squared, right? But now this x squared has a x and then another value here with it. So when you see that there, you know it's vertex form. And when x is with another value like that at the beginning, we know that there's a horizontal translation. And we're going to do more practice. It'll be more clear by the end, hopefully. Okay, lastly here. What about the y-intercept? So, I want you guys to fill this in. We need the equation in standard form. So sometimes you might be asked, what is the y-intercept of giving this equation in standard form? And I'm going to show you how to do that. In order to be able to get the y-intercept, we need to expand the equation and simplify in order to put it into standard form. Well, first of all, remind me, what is standard form? How does that look? You guys know this. We've done this 100 times over. What's standard form? Ax squared, then good. Ax squared plus bx plus c. So we want to take this equation and we want to put it into standard form. Well, how are we going to do that? So I'm just going to write the original one first. How are we going to do this? How can we expand and simplify? Well, what does this really mean when there's a 2 on it? How many of them are there? 2. x times x is? X times 2? 2 times x? 2 times 2? Plus 3. X squared, 2x plus 2x? 4 plus 3? Now, if you guys recall, and this was a while back, but when we were doing standard and factored form, we learned that this c value here, right, it's our c value, is the y-intercept. Okay, we learned that. That's just something that you need to remember. So now that we put it into standard form, we can say that our y-intercept is 7. So use the c value. Or you could sub x equals 0 into function and solve. But I mean, that's not very necessary. And please don't, this or sub x equals 0 into the function and solve, that's like grade 9 stuff. You guys know how to do that. We did that at the beginning of grade 9 review. Remember when we were trying to get the x and y intercepts? If you want to get the x-intercept, you make y0, and if you want to get the y-intercept, you make x0. Is it kind of ringing the bell? Okay, so in this case, if we just put it into standard form, then our c value is the y-intercept. If you didn't do that, then you could sub x equals 0 into the equation, and you would get y. Okay, so let's see. 0 and 7. Well, is this the point where the parabola crosses the y-intercept? Or y-axis, sorry? Yeah, that's 7. Okay? All right, I know this is a lot. We have a little bit more to go. Well, we only have 20 minutes anyway, so we'll have to stop then. Okay, another table here. So now we're going to compare y equals x squared to vertex form, y equals x minus p squared. So let's do another table. So, value of p. Well, remember, this is where p is. So for this guy, what's the value of p? 0, right? We don't have that. This looks like this. So p, it doesn't exist. It's 0. What's the value of p here? Okay, so this is where it gets confusing. No. So remember, this here, okay, so this is standard form. Okay, hopefully this will maybe make more sense. This is the equation that we have to plug p into. So this is always here no matter what. So really, p in this case is negative or positive 2. Positive 2, and that's where I know it can get confusing. It's the opposite. It just is what it is. If this said, if it did say plus, then you know it really looked like this. X minus negative 2. This becomes positive, which would make it y equals x plus 2. Are you guys seeing that? I know that it's a little bit confusing. Okay, so if we see a minus here, it actually isn't negative 2 because the minus is already there. If we see a positive, then we know it had to have been a negative to turn to positive. Does that make sense? Okay. Yep. Okay, so we're asking for the value of p here, right? And if we look to this guy right here, let me take that positive off now. If we look to this equation, well, we're going to look at it and say, okay, well, up here this is our general vertex form, right? And this guy is in this form, right? Y equals x minus p squared, okay? We're trying to say the value of p here, so it's only natural to say that the value of p is negative 2. But it's not negative 2 because this negative is always here to begin with. So in this case, the value of p is just 2, positive 2, because if it was negative 2, it would have looked like this, x minus, and then negative 2 in brackets, and then the negative 1 times the negative 2 makes it positive 2. Yep. That's right. So if this is confusing to you, all you need to remember is it's really the opposite. Just remember it's the opposite. If you see a plus in here, it's really P is negative. Okay? So, yep. That's right. Yeah, you could, but this isn't really simplified, right? We don't leave things looking like that because this really is -1 times -2. Would I change this to this? Yes, that's why this looks like this. This is me just showing you how we got here. Are you saying, is this going to change? No. You're just, no. Keep it simple. It would just, really, this was just to show why this p-value is +2 and not -2. That's it. And then we're done here. That's the p. Okay? So I'm going to erase this. Do you want me to erase this, or do you want me to leave that up for the notes? I'm going to erase it because I don't want it to confuse you. I'm just showing you up here why this p is positive and not negative. Okay? Because this is already part of the equation, which means that this must be positive. Because if this was negative, this would turn to positive. Okay? Okay, so having said that, +2. What's this one? This one? Good. Good. So, honestly, if that part's confusing, just memorize it. It's the opposite. If there's a plus inside, the p is really negative. If there's a negative inside, the p is really positive. Okay? Okay. And now I want to put this here because this is also something that you need to memorize. So if p is positive, you are always going to move or horizontally shift the parabola right. And again, this could also just be something you memorize. Right 4, left 2, left 4. So this is another thing that we're going to be seeing in the examples that we do. If p is positive, you're going to move right. But if, and this is important, I want you guys to pay attention to this part. If that is confusing to you because it's really the opposite, because right now we're saying p is positive, so we're going to move to the right. But when you look to the equation, p looks negative, right? So you might want to memorize it this way, but if I were you, I would just memorize it how it looks here. So when you see a negative in the equation, it's going to move right. When you see a positive, it's going to move left. Do you guys see what I'm saying, how it's the opposite? So you could realistically memorize it this way, but I think this is more difficult because you could say, well, when the p-value is positive, it's moving right. When the p-value is negative, it's moving left. But when it looks like this, really the p looks negative here, right? That was the whole point of us doing that thing up there. So instead, I would just memorize when it's subtraction or negative in the equation, we're going to move right. When it's adding, we're going to move left. It's just the opposite. So it's however you want to memorize it. Okay? Yeah, this is probably for sure the most difficult part of the lesson. So again, practice makes perfect, right? Direction of opening. Okay, so remember, this is still our A here. So can you tell me for every single one of them, what direction are they going to open? Up, good, because it's positive. A is positive. Vertex. Vertex of y equals x squared is always 0, 0. Now I want to come back here, because this was an example where we saw a vertical shift. Actually, no, that's going to confuse you. Never mind. Let's just look at it here. So now, when we are shifting left and right, one of the values of the vertex is going to change. Well, when we did vertical shift, which value changed? When we did up and down, which value of the vertex changed? Y. So when we do left and right shift, horizontal translation, which value do you think is going to change in the vertex? The x. Good. So 0, 0, this is the p-value. So that is going to become your x value. So I'm going to write that up here. Change the x value of vertex. Now you'll see why this is important, why we had to do this. Because here, p looked positive, but we know now that it's really the opposite, it's negative. And we need this for our vertex. Okay, so now our x is going to change and our y will stay at 0. So what's going to be the x value of this vertex? Positive 2. Okay, so again, you're going to look here and say, oh, it's negative, but no, it's really positive. So 2 and 0. What's this one going to be? 4 and 0. What's this one? Negative 2 and 0, and negative 4 and 0. Okay, axis of symmetry. Well, we know it's always the x value of the vertex. So we're so used to always writing x equals 0, but in these cases, is x equal to 0? No. So here, x is what? Yep. But here, x is 2, x is negative 2, x is negative 4. And then for here, I want you to write shifted left or right. The vertex is what tells us that information. Okay. So remind me, this is shifting left or right to? Right. Left or right to? Okay, just something you have to memorize. Okay. Okay, a couple things down here. Okay, you got that down. I just need to email Mrs. Tarantello real quick. Okay. We're getting there, guys. 3 more slides. Okay, so it says here the graph of y equals x minus p squared, which is our vertex form, is the image of the graph y equals x squared after a horizontal shift right or left. So that's what we're seeing now. When we see the equation looking like this, we know that there has been a shift left or right. So the horizontal shift right, if p is greater than 0, so remember here, p is greater than 0, so we're going right. Horizontal shift left, if p is less than 0, okay, so less than 0, left. And then equation for the axis of symmetry is x equals p. So when it says that x equals p, really in the vertex, p, q. Remember xy, xy, p, q, because now we have a p here instead of an x or a y, because we already have an x and a y. So please don't let that confuse you. The p is really the x value. That's why it's saying x equals p. To get the axis of symmetry, we looked at the x value of the vertex, which is this number here, which is really p. That's why it says x equals p. Now, you also might want to remember it this way. When it's a negative inside the brackets, you're going to move right. When it is a positive inside the brackets, you are going to move left. Okay, so this is how it's going to go. We're going to do this next page here. This next slide, sorry, it's just a summary slide. Once we do this slide, you guys are going to go for break. When you guys come back from break, we will have 2 slides left. Then we will talk about any questions for the quiz, and then you'll get started on the quiz. Okay? Okay, so this is just like a very much a review, putting it all together page. So if you're struggling and you're like, oh, there's all these slides, come back here. This is where it puts it all together. Okay? So, what do I want you to put on this page? Equation for the axis of symmetry. X minus p equals 0, or x equals p. Let's just focus on this. X equals p. This is what we just saw in the last slide. Right? X equals p. P is really the x value of the vertex. So again, this is vertex form, right? This is what we've been looking at. Here's our p, here's our q. The q is what tells you the vertical shift. This number here is telling you the vertical shift. And this is everything that we've seen so far. So if it's a positive, then it's going to shift up. If it's a negative, it's going to shift down. Here, horizontal shift left or right. So it's this here that is telling us the horizontal shift. We know that if p is greater than 0, we're going to move right. If p is less than 0, we're going to move left. Okay? Or you could just remember it based off these signs. Remember? If there's a negative in the bracket, we're moving right. If there's positive in the bracket, we're moving left. Okay, so you're going to see equations that look like this. And this is a nice summary page. It's this value here that is telling us if it's shifting vertically. It's this value here that's telling us if it's shifting left or right. Now, vertical stretch or compression, something else we've learned. Well, that is all about the A value. Remember? So if A is greater than 1, we're going to see a vertical stretch that looks like more like that, remember? If A is in fraction, so it's greater than 0 but less than 1, it's going to look like that, a little bit fatter. And then if there is a reflection in the x-axis, we know that we have a negative A, and it opens down. And guys, I know this, it's a lot. It is a lot. But it's stuff that we have to memorize, and we have to do the practice questions, and the last 2 slides is really putting it all together. Okay? So hopefully after the last 2 slides, we feel a little bit better about it. Okay? So that's really it. Axis of symmetry up here, reminding you how to get it. This is telling you that the Q is talking about the vertical shift, the P is telling you the horizontal shift, and then the A is telling you if there's a stretch, compression, or reflection in the x-axis. Okay, so the last 2 slides, we're going to see a whole bunch of examples that look like this with actual numbers, and we're going to actually say everything that's happening with that equation. Okay, go for break. Good job so far, guys. 2 more slides. 2 more slides.